CFRP. My thesis was entitled Effect of Carbon Fiber Reinforced Polymer Strengthening on the Axial Capacity and Ductility of Non-Cylinder Square Concrete Columns. I was ably assisted by Dr. Mumenya and Dr. Mwero of the Department of Civil Engineering. My presentation is outlined as follows. There will be a bar on the right that will highlight the section I'll be presenting on. To give you a little background, carbon fiber reinforced polymer, or CFRP, is a composite material which relies on the carbon fiber to provide strength and stiffness, while the polymer provides a cohesive matrix to protect and hold the fibers together. CFRPs are used in aviation, shipping, automotive industries, bicycles, and civil engineering structures. In this study, CFRP was used as a column in different configurations to strengthen concrete columns. In practice, our C columns are composed of concrete that bears most of the compressive stresses and steel that bears most of the tensile stresses. Quality control measures, such as the use of cube crushing tests, are usually conducted on structural members, and if they do not meet these strength requirements, then they could be condemned for demolition. However, demolition is very expensive financially, time-wise, and to the environment. Alternative options to avoid demolitions are the use of steel angles or the use of CFRP. CFRPs are commonly used in seismic-prone countries. Some advantages of CFRP are its high strength, lightweight, corrosion resistance, and ease of use. Some of the disadvantages are that it's easily damaged and it has poor response to fire. Why would we need to retrofit? Mainly because of design inadequacies and poor construction practices that are manifested in building collapses. To put this into perspective, in 2018, an audit report of about 1,500 buildings showed that 44% of those buildings were unsafe for occupation. In addition to that, because of the global phenomenon of rural to urban migration, engineers may be required to increase the capacity of existing buildings to cater to that increasing population. So it is against that background that the experimental study was conceptualized. From an academic standpoint, most literature implies that the change in behavior of CFRP strengthened columns is due to full confinement. Nonetheless, some CFRP manufacturers claim that partial confinement offers similar benefits to full confinement with less material being used. This study set out to prove or disprove that claim. So there were 4 research objectives based on concrete grade, steel reinforcement, degree of confinement, and the number of layers. 4 research questions guided the study, and 4 hypotheses were formulated. This study is essential as it will provide necessary guidance to increase the load-bearing capacity of structures, to reinforce buildings wrongly constructed, and to fine-tune the parameters used in the structural design process. One assumption made was the use of prescribed ratios proposed in the IQSK manual, although there's a slight difference with the Indian standard, since its prescribed ratios are a step lower than what we have in Kenya to achieve the same target strength. The scope of this study was limited to square columns, and the axial capacity and the ductility were the only dependent variables investigated. For economic reasons, 2 layers and 1 brand of CFRP was used. The study dug into a lot of literature and found that CFRP took advantage of the Poisson's effect in improving concrete strength by confinement. So when a vertical concrete column is subjected to uniaxial compression, the concrete deforms in the longitudinal direction as it expands in the transverse or lateral direction. This is the Poisson's effect. So CFRP strengthening works by providing external confinement to the column and limiting that transverse and lateral expansion. Other factors that influence the behavior of confined concrete are the concrete characteristics and the confining material, that is CFRP, and the cross-section characteristics. So this was learned from other studies that had been done on concrete grade, and it had been shown weaker concretes gain more in axial capacity and ductility. Some studies had also been done on the number of thickness, but for reinforcement, as far as the author of this study is concerned, there were no studies comparing plain and reinforced concrete. In terms of degree of confinement, most literature is based on full confinement. Guo et al. And Guo and Zheng recommended that partial confinement be compared with full confinement. The theory of Poison's effect guided the study, where the concrete grade and reinforcement affect how much the column deforms laterally. Those are the intrinsic values, and the degree of confinement and the number of layers restricted that lateral expansion, extrinsic values. This is simplified in a conceptual framework where there are 4 independent variables and 2 dependent variables. And this guided the experimental investigation where there were 3 concrete grades: in plain concrete and reinforced concrete, in partial and full confinement, 1 layer, and partial and full confinement, 2 layers. To improve the reliability and credibility of our data, then 3 samples were made for each specimen. In the write-up, this is represented in the matrix format shown, and the study came up with a total of 90 column specimen samples. Sorry, this is the graphical representation where A and B are the reference specimen without CFRP, and specimen C to J are the specimen with 1 layer, and specimen G to J are the specimen with 2 layers in partial and full confinement. The molds were manufactured using marine ply, and old engine oil was used as the shutter release agent. Quality control measures such as the use of reflux was used, and quartering to ensure homogeneity of our samples. On the left is the samples immediately after removal from the water bath, and on the right is a picture showing the samples just before application of CFRP. Carbon fiber was cut to size using an ordinary pair of scissors, and to bind the carbon fiber to the columns, an epoxy set is usually required, a combination of a resin and a hardener, mixed in the ratio of 1:2. The epoxy was mixed and applied according to manufacturer specimen, with the safety precautions being taken throughout the study. This is the pictures of the final specimen that were used. The test setup is as shown. It involved a hydraulic actuator powered by electricity that pushed a piston upwards, providing compression to the clamped specimen. The procedure involved 3 people. The first person was at the switchboard and read off the values of load from the scales, while a second person read off the values of deflection from a strain gauge, while a third person recorded what person A and person B were reading out loud. The results were then calculated, and the values were then plotted in typical, and the stress strain curves were plotted. They basically had elastic phases and plastic phase. The axial capacity of all the 90 specimen was done on bar graphs for concrete C810, C1215, and C1620. Then specimen C to J were compared with the reference, with the control samples A and B to get this bar graph. To further illustrate the trend, the averages of these values were calculated, and it was found out that indeed, the weaker the concrete, the higher the effect of CFRP. In line with the second objective, then the effect of rebar on columns without CFRP was also undertaken, and the trend was also similar to that of concrete grade. In addition to that, the study also wanted to find out the effect of rebar on columns with CFRP. So 4 comparisons were drawn. Comparison A was drawn to find out the change caused by rebar on columns with CFRP. Comparison B was drawn to find out the change caused by CFRP on plain specimen. And comparison C was drawn to find out the change caused by CFRP on reinforced specimen. And lastly, to get the combined effect of both Rebar, and CFRP, then comparison D was drawn. In line with the third objective, then the degree of confinement was compared, and full confinement was more effective than partial. And as per the fourth research question, then the answer was that 2 layers was more effective than 1 layer. The same analysis was done for ductility, where the final ductility was calculated for concrete C810, C1215, and C1620. Each of these specimens had 3 samples each, and the results were also presented in bar graphs as shown. That's for rebar, for concrete grade, for rebar. And finally, an interesting concept observation here on the effect of rebar on columns with CFRP was comparison A, where rebar seemed to cause a decrease in ductility, contrary to what had been expected. This was attributed to the reinforcement, causing a reduction in the passive confinement pressure. In regards to degree of confinement, then full confinement was more effective, both in ductility and axial capacity, thus disproving the manufacturer's claim that partial confinement offers the same benefit as partial confinement. With regards to 2 layers, as expected, 2 layers was more effective than 1 layer. To find out the impact of the 4 variables, the data was presented in a radar chart. A radar chart is a graphical technique of visualizing multivariate data. So in this case, concrete C810 had the highest effect, followed by 2 layers. The best way to present this sort of hierarchical information is through the use of tree maps, shown here. So on the top left is concrete C810, which had the highest effect, followed by 2 layers. The same procedure was done for ductility, and it was found that 2 layers had the highest effect, and using 1 layer had the least effect. The failure modes were then discussed. Failure modes of the various specimens were then discussed, and their findings made, where the first hypothesis was accepted, the second failed to be accepted, the third and fourth were accepted. The greatest takeaway of this research was the material efficiency, where a single full layer confinement was compared to double partial confinement. In this case, a material saving of 14.3% was realized, and in terms of mechanical properties, then double partial confinement was more effective in axial capacity as well as ductility. Some challenges experienced in the study was that some equipment was not available, and some human factors such as fatigue led to some non-uniformity of the samples manufactured. To verify the experimental methodology, the stress-strain curves were compared with formulas in literature and were found to be similar. The results herein were also similar to other studies, as shown by the results of Guo et al. And Wang et al. Random samples were also manufactured later and retested. The results were similar to what had been found initially. The machines had also been calibrated by the Kenya Bureau of Standards within a year of doing these tests. And lastly, the failure modes were satisfactory, eliminating the existence of a probable fault in the machinery. With the experimental methodology verified, then 4 conclusions based on the concrete grade, steel reinforcement, degree of confinement, and the number of layers was made. Recommendations were made from the study, including a design proposal in Appendix F. This proposal was also adopted in site, where the bottom columns had 2 layers of CFRP, and at the top, actually none was applied. What's that? Recommendations for further research are also included, and the references that were used are hereby included. The University of Nairobi School of Engineering guidelines were used. Those guidelines were not comprehensive, then the APA 7th edition was used. An open source citation manager, Zotero, was used to keep track of the references. The appendices include the drawings for the molds, the details of the specimen that were used in the manufacture, some calculations and correspondence details of the author. The last item in the write-up is an index of key terms. Acknowledgement is made to CGP consulting engineers for providing the materials necessary to conduct this research. 2 conference publications have been made in the AEC 2020 and the IK conference, 1 paper publication and 1 paper based on the first research question is still pending. Thank you for your time. If you have any questions, suggestions, clarifications, or improvements, I'll be happy to hear.